structure is structure which we are trying to obtain from the IAR filter. For obtaining your lattice ladder structure, it is this structure looks similar to your lattice and a ladder structure. Your lattice is nothing but a crisscross type of your structure, okay, and your ladder, it similarly looks like a ladder. That's the reason we call it as a lattice and a ladder structure. So we can see here in the figure, the top is the lattice structure, and the second half portion of my figure here is looks like a ladder structure. That's the reason we are calling it as a lattice and a ladder structure. Okay, and how to obtain the lattice ladder structure? To obtain our lattice and a ladder structure, we should find out the coefficients, and that particular coefficients. Of course, there are two things we have to find out: the forward tap coefficients, that is forward, what we call it as a forward the tap coefficients. The other one is your lattice coefficients, that is the lattice coefficients and the ladder coefficients. Both the coefficients we have to find out, and to finding out the lattice and the ladder coefficients, that is the given transfer function h of z is being divided into two things, calling it as b of z by a of z and b of z. Your a of z, that is I'll be considering the poles, that is the poles which is given from the given transfer function, and that is the given transfer function. The poles I'll be calling it as a of z, and the zeros I'll be calling it as a b of z. Okay, so I'll be considering both the poles and as well as the zeros. So the poles I'll be calling it as a of z and the zeros as b of z. Then I'll be just considering only the lattice coefficients. The lattice coefficients have been obtained from the poles of the given transfer function. That is from the poles. That is nothing but I'll be considering what the a of z term. Okay, so from how to find out a, that is the coefficients from the a of z, that is we have to remember this simple two formulas, that is the lattice coefficients for a of z are found as follows. For m is equal to n, that is what is n here, the order of the filter, that is here. If we just look sorry, if you just look into the transfer function, given transfer function, my m is equal to order 3. Okay, so the order is equal to 3, so that's a reason m is also will become 3. So I have to find out the coefficients, three coefficients I have to find out. For finding out the coefficients, of course we have to remember this particular formula, that is am of I, am minus 1 of I, which is equal to am of I minus am of m into am of m minus I divided by 1 minus km of square. And my I value varies from what? I value varies from 1 to m minus 1. Okay, so this particular formula we have to remember to find out the coefficients, that is the lattice coefficients. The first step is, of course, here n is equal to 3, so that my m is also will become 3. So first I will be trying to find out my k3. I can directly obtain my k3 from this particular formula, that is km is equal to am of m. From this, k3 is equal to a3 of 3. a3 of 3 is directly obtained from the given transfer function, which is nothing but 0.0276, which is directly obtained, that is been copied directly from your transfer function. This is the value, that is 0.0276, that is your k3. Okay, then what about your a2 of I? a2 of I is nothing but you have to substitute my m value. The m value is 3 minus 1, so it will become 2. So a2 of I uh, will be getting as a3 of I minus a3 of 3 into a3 of 3 minus I divided by 1 minus k3 square. In that I have to substitute I is equal to 1 and I is equal to 2. By substituting I is equal to 1 and 2, I'll be getting the values of a2 of 1. My a2 of 1, that is substituting everything in the obtained equation, that is a3 of 1, a3 of 3, a3 of 2, all those parameters will be obtained from the given transfer function itself. So from those transfer function values, after replacing a3 of 1, a3 of 3, a3 of 2, I'll be getting a2 of 1. Once we get of a2 of 1, the next thing is once again we have to substitute for a2 of 2, that is a2 of 2. After substituting the values in the above equation, I will be getting at 0.3485. Okay, then that will not end, because for the earlier case we have taken as m is equal to 3. Now I have to reduce my m is equal to 2. That is, we have to take my m values from 3 to 1. Okay, in the what we call it as a descending order. Okay, from the higher value to a lower value. So here it is m is equal to 2. Similarly, for m is equal to 2, substituting for k2 and a of 1, I'll be getting a of 1 value. Then for m is equal to 1, I'll be directly getting my k1 value, k1 which is equal to a1 of 1, that is minus 0.2132. Once we get the values of k1, k2 and k3, that I can write down in a form of what we call it as a lattice structure. The lattice structure we can see here. This is how to write a lattice structure. We can see here the lattice structure from your input x of n to my v of n here. Okay, which we have to take with the delay elements. Here the order of the function, given transfer function, is 3. So the number of delay elements what we required is will be once again directly proportional to the order. So it is 3. In this 3 we have found the values of k1, k2 and k3, which we have written in a form of a lattice structure, that is a crisscross structure. So from this we can directly write out k1. K1 is equal to minus 0.2132, which we have directly obtained from the calculated values from k1, uh, k2. Okay, so k1 is equal to 0.2132, k2 is equal to 0.3485, and k3 is equal to 0.0276. Okay, that is with respect to your lattice structure. Then we have to consider the ladder structure, that is we have to find out the coefficients of your ladder, that is nothing but what we call it as the forward tap coefficients. The forward tap coefficients has been found by this particular simple formula, beta of I, which is equal to bi minus summation of m is equal to I plus 1 to m, beta of m into am into m minus I. Okay, in this what is my I value? I value varies from m minus 1 up to 0. From this particular formula we have to find out the forward tap coefficients, and of course to find out the forward tap coefficients I have to consider starting from m is equal to what? The order, that order is 3 here. So for we take m is equal to 3, and then we'll be substituting my I values. So here I value is equal to what? M minus 1 up to 0. So it will become 3, 2, 1 and 0. So we have to start from B3, uh, B3, then B2, then B1 and B0. Okay, so finding out B3, which is equal to, directly I will be getting from the coefficients value from the transfer function itself, which is equal to 0.29, which you are directly taken from where? From the transfer function itself. Transfer function itself, that is we can see here it is 0.129. Okay, so we are directly taken from the transfer function. Next, if you see the remaining parameters, B2 is equal to what? Beta of 2, which is equal to B2 minus summation as m is equal to 3 to 3. In that I'll be getting m is equal to 3 to 3. That is no need of substituting m is equal to 3 to 1, all those things. So it is 3 to 3 itself. So it will become beta of 3 into A3. Here m value is what? M value is what? Here 3 minus 2, it will become 1. Okay, so after substituting the values, we'll get beta of 2, which is equal to 0.4252. Similarly, for the next case, m value varies from 2 to 3. So it will become what? 2 into 2, a beta of m is equal to 2 into 2, then beta of m and the a of m will become 3 and 3. Okay, so we'll be substituting for both, for m is equal to 2 and as well as m is equal to 3. Then when m will become 1, I'll be getting for all the 3 parameters starting from 1 to 3. So 1 into 1, 2 into 2 and 3 into 3. Okay, so once we get all those parameters starting from your beta naught, beta 1, beta 2 and beta 3, I'll be writing down in this particular ladder structure. So starting from the lower order, that is beta of naught, which is equal to 0.331, then beta of 1, then beta of 2 and beta of 3. Okay, so by doing this, my lattice and ladder realization for IR filter will be obtained. Okay,